Sweet, we are live now. Yay. Yeah. So one, it's pretty easy because it's all it's asking you to do is figure out like what the which things are equivalent.
Right.
So all you got to do is you could do it the backwards way where you just figure out okay what is the actual equivalent to it and solve. What I did is I just solved all of them, and if they're equivalent, they should all come out to the same answer. So for example, the first one, sine of 6 is equal to the negative sine of negative 6. And then sine of 6 minus sine of 4 is equal to a, which is, let's say, 2 cosine 5 times sine of 1. So that's the easiest way I found to do it. I'm sure there's a different way of doing it, but if it just needs to be equivalent, they should equal the same thing. So you just run through a calculator and it'll give you the answers, then you just match them up.
Gotcha. And so you said you got one. So you got one, 2, and 4.
Yeah. So number 3, I'm not sure how to do it, but 2 is easy. They're found in the book. There's 4 equations. I just needed to pick one, so I got cosine of x minus cosine of y is equal to negative 2 of sine of x plus y over 2 times sine of x minus y over 2. They're just in the book. You just need to type into the search thing product of sum. It'll give you 4 equations in a little chart.
Gotcha. So 3, find all the angles is that sine, or is that just in?
All the angles alpha in 0, comma
2 pi.
Yeah, 2 pi. That satisfies the equation. Sine
2a equals tan alpha.
Yeah.
Oh, I'm trying to think. I remember seeing something about this
Yeah,
in the PowerPoint.
Don't remember exactly what it was though.
Yeah, I just pulled up the PowerPoint now and look and see what they say. Level tangent. Find all the angles. It's like the k pi something. Let me see really quick. Solve it. Trying to think how you solve for it first, because I think I know how to do it once you solve for it. But how do you solve for a angle or alpha?
That's the problem. I don't know either.
Sine tangent. You just put it like sine alpha over cosine alpha equals sine 2 alpha.
Maybe.
How do you solve for that? Or would you just do? I mean, if you do like So when I get how to get the alphas together. So you have to get the alphas together because if you do like arctangent both sides, you get alpha equals arctangent sine to alpha. But then like you have alpha in there still, so it doesn't really help at all. Or do you make it, what if it's sine 2 alpha minus tan alpha equals 0, and solve for alpha that way. Isolate them from both sides. Then use an identity maybe to, well, I can't really do that because there's a 2. Get 2 out of there. We're seeing something about this too. Let me see if I can use the other PowerPoint sheet to get in this.
Is it still be number 3, right?
Yeah.
Okay, yeah.
Preparation. What was preparation? No, it was resources. Yeah, reduction. Oops. Okay. Reduce 2 trigonometric functions to 1. If you have these, yeah, the reduction theorem. Was that? I don't know if that was it. Might actually have been something else.
All the rest of the questions weren't all that hard. This one's just driving me up the wall.
Yeah.
Outrage after an autopsy report. Family members say it's murder. So far, no prosecution tried to file charges. Part of it. Order Ellis Michael spoke to the victim's family exclusively. Drugs is now.
There, yeah, there's the one. Sign to, that is what? So there's a sine 2 angle that you can put in for, and it'll be 2 sine alpha cosine alpha, the double angle identities. I don't know if that will help or what, but it might. So that 2 alpha in there is just what's kind of.
Yeah.
Tangent. um, Cosine over cosine. Cosine alpha, and you pull out sine. Hmm.
Excuse me.
Hmm.
Yeah.
So that's sine 2 times angle. So solve for that. You need to find alpha. I just don't know how to get alpha out.
Yeah, it's kind of similar to what we were doing on the preparation assignment. They had one that was similar to it. It looks like, at least. You got to
Yeah.
solve for it, but without using a calculator. I'm trying to remember how you do that. You can look back at that. Be that hard. Going through the book right now, just checking to see if there's anything that matches up with any questions like this.
Yeah, that's what I've been looking through, is trying to find something.
Try going to page 472 in the textbook, and I think there should be one example 6 at the bottom of that page.
Okay.
So it kind of looks what you have to do is, yeah, you're right. You have to solve to get the basically to get rid of all the trigonomic onto one side.
Mm-hmm.
So what they did first is their equation was sine 2x is equal to sine of x, which is similar to ours. And what they did is they got it equal to the same thing, where they had sine 2 of x is equal to sine of x is equivalent to 2 sine x cosine x is equal to sine x. And they got the sine x on the right over to the same side, so it was 2 sine x cosine x minus sine x is equal to 0. Factored it out, so sine of x parentheses 2 cosine of x minus 1. And then from that, set each factor to 0.
What page is that again?
472, very bottom. Trying to figure out how to apply this to our problem is the only thing that's tripping me up.
Okay, I think I know. So change it like they did. So sine 2 alpha, make it 2 sine alpha cosine alpha equals, instead of tangent alpha, sine alpha over cosine alpha. And then,
So change that to sine alpha over cosine alpha.
right. And then multiply each side by cosine alpha. Get rid of the one in the bottom, denominator.
Oh, okay.
And then
Okay.
that'll be 2 sine alpha cosine squared alpha equals sine alpha. But then you can subtract it like they did. So 2 sine alpha cosine squared alpha minus sine alpha equals 0. And then you can pull out the sine alpha. So it'd be sine alpha times 2 cosine squared alpha minus 1 equals 0. And from there, is there an identity we can do with that?
I'm not sure.
There's, I mean, 2 cosine alpha, there's not, but cosine squared alpha minus 1, you'd be able to put sine alpha. Um,
Could always factor it.
yeah, can you factor out the 2?
And the 2, no, that's the difficult part. I don't-
You'd have to make that minus 1/2,
yeah.
which doesn't work. Yeah, because that would work then, because that would just be sine squared alpha, and that times the other one would be sine. How do you get rid of the 2? Dang that 2. Man, that 2 just screwed everything up. Wait, they have a 2 in there too. How do they
Yeah,
get rid of that 2? Oh, so they. Oh, okay. So I see what they did. So they had it's either one or the other. So sine alpha equals 0, or you do cosine squared though. That's the only thing. Because what they did is they just did. Then it was just 2 cosine squared alpha minus 1 equals 0. Solve for that, and then that. That would just be cosine squared alpha equals 1/2. Can you square root the 2 or the cosine? Could, can't you? Because then it
Yeah.
would be cosine squared alpha equals 1 over the square root of 2, which is
2.
a side length, right?
Yeah, 1 over square root of 2.
Or, yeah, because you would do the square root of 1 is 1, and so
Yeah.
the square root of 2. So it would be. So you just have to find out what that is.
Convert it from radians to. Not from radians, convert that to degrees. What is that?
We don't have to do degrees, because what they have out here is they're like, it's a plus 2k pi or whatnot. So it'd be like cosine alpha equals that. So alpha would have to be pi fourths. Or, yeah, because anything cosine or anything that's pi fourths is a 1 over radical 2. Right. So, but that could equal more than just that. So you could be, it's cosine, so it can't equal anything negative. So it can't be, because cosine is the x value, so it'd have to be in the first and fourth quadrant.
Yeah.
So it would be like alpha equals pi fourths plus, and then that's what throws me off, is like, what? How do you get both of those? Because it can be pi fourths, or it could be what's in the bottom there, 7 pi fourths.
I think so. Yeah, that seems right.
And so the way that it would go is it'd be pi fourths plus 2 pi or 2k pi, and then 7 pi fourths plus 2k pi. But then for the other one with sine alpha equals 0. Sine is the y value, so it'd have to be 0 or pi. No,
2.
yeah, 0 or pi. 0 plus 2k pi, or then pi plus 2k pi, I guess.
Yeah.
So if that's right, how do you put that? 0 plus 2k, because 0 plus 2k pi continue being 0. Or it would just be 2k pi. So that makes sense, because every time it would be 0 or pi. Does that work though? It's like solve for it.
I think so.
2 pi, sine of 2 pi would be 0, and then tangent pi. Let me test those out really quick. I don't really want to solve it in my head. Use calculator. Just to, not to solve it, but just to verify that that's right. Yeah, so that's 0. And then tangent pi is 0 too. So pi works.
That works.
And then if you do 0, oops, 2 times 0, gosh dang it, 0, that's 0. And tangent 0, oops, gosh dang it, is 0. And then 2 times pi fourths equals 1, and then tangent pi fourths is 1. And then the last one was 7 pi fourths. That's negative 1. Negative 1. Yeah, so those are right. And then I guess, yeah, just plus 2k pi. Because the plus 2k pi just means, because like the circle can go around and around as many times as you want. And so technically it could be a bunch of different, I mean, it could be like, you know, I don't know, like 14 pi fourths. So they can go around and around and around. But the 2k pi just means that it's everywhere where it hits. Every time you go around where it hits there, that is an answer.
Mm-hmm. Yeah,
So,
and that weird spiral thing going out.
yeah.
Yeah.
So those are the answers, I'm pretty sure. So the answers, alpha would be pi fourths plus 2 pi, or 2k pi, 7 pi fourths plus 2k pi, and then 0, and I don't know if 0, how you do that with 0, but
So 7
0.
7 pi fourths plus 2k pi again.
Mm-hmm.
Okay.
And then 0 plus 2k pi, and then pi plus 2k pi. I guess. Wait.
I guess we'll see if that's right.
So they work. I just don't know how. I don't with either two, with the 0 and pi. I just don't know how to put the 2k pi in there so it makes it, because that doesn't seem right. At
Yeah.
least the pi, like the answers are right. I just don't know. I don't know if that's the right notation to say that that will hit every time.
I don't think she'll ding us too hard for not simplifying enough on that.
And hopefully explain a little bit on how to do it for the test. Well, I guess the test is she won't have it done by then,
Yeah.
right? Okay. Well,
We'll find out.
right?
Gosh, yeah. Okay. Well, that sounds done. 4 isn't too bad. You just throw it into a into one of those. What was those things called again? Into one of those identities, and the identity I chose made it be. Let's see where we're at. The sine 285 minus sine 15 is equal to 2 cosine 285 plus 15 over 2 times sine 285 minus 15 over 2. Those both simplify down to 2 cosine 158 times sine 135. Then from there, you just solve each of those, the cosine 158 and the sine 135, and simplify them down.
Yeah.
Easiest way to do it is to split cosine of 150 into cosine of 60 plus 90. Separate those two out because those two are pretty nice. So then you get cosine of 60 times cosine of 90 minus sine of 60 times sine of 90. Because cosine of 60 is 1/2, cosine of 90 is 0, sine of 60 is square root of 3 over 2, and sine of 90 is 1. So once you run that through that equation again, so 1/2 times 0 is 0, minus square root of 3 over 2 times 1 is equal to negative square root of 3 over 2. And then you do the same thing for sine of 135. Simplify that down to sine of 45 plus 90, break it down again, and long story short, you get square root of 2 over 2. And then you throw that back into your original equation, so it's 2 times negative square root of 3 over 2 times square root of 2 over 2, which just comes out to be pretty much negative square root of 3 divided by 2, or that whole entire thing is square root. So it's the negative square root of 3 over the square root of 2.
Gotcha. Hey guys, I have to run really quick. My wife needs help with something really fast.
Oh, no worries. That was the last question, so we're good.
Probably good then.
Yep, we're good to go.
Okay, cool.
Good luck
Sorry
on the
about that.
test. No worries, man. See you on Tuesday.
See you guys.